I have set up a, a little clinical example of electron fields in the treatment planning system. I've used a body phantom called a rando phantom, which is an epoxy with a simulated bone material embedded in it, but I basically overridden the density to that of water, just to negate any sort of variance we might have with um, heterogeneities. This is going to be a pretty close approximation to whatever percent depth dose curves you see in the soft chalk. The only minor differences are the shape of the isodose line. Since we're not quite on a perpendicular or flat surface, there's a little bit of concavity to the isodose lines. But I think the point will be illustrated here. I've set up 5 fields. Field 1 is 6E, and then 2, 3, 4, 5, each 9, 12, 16, and 20E. And what I wanted to do was go through the isodose curves as well as the percent depth dose when giving a set number of monitor units. So if I dial up 100 monitor units for 6E, I wanted to kind of go over the percent depth dose curve here and the characteristics that are seen in the soft chalk lecture. So you have a skin dose, you have a surface dose, we have a Dmax, which in this case is right around 1.4, 1.3, and then you have a rapid fall off. You have extraordinarily rapid fall off. R sub P is the practical range. Take the tangent line down the steepest slope of the percent depth dose curve. It takes you right around 3, which is 6 divided by 2. So the energy divided by 2 gives you the practical range. And then after the practical range, the only dose to the patient comes from Bremsstrahlung contamination within the head of the machine. If I zero out 6E, so let's put the field weight at 0. You notice what ends up happening, my skin dose goes up. So right now I'm about 85%. I have Dmax right around 2. And then my steep slope, if I trace the tangent line down, is 4.5 is my practical range, which is 9 divided by 2. After that, I get a Bremsstrahlung tail right around 1%. If I look at the isodose lines, you can see that I'm deeper in the patient. Contrast this with 6, put this on interactive apply. So 6E isodose lines, 9E isodose lines. If we go to 12, 12E isodose lines, you can see how these lower isodose lines keep moving deeper and deeper and deeper in the patient. Even at the 95% isodose line, you can tell it has a broader range, and this makes sense because the higher electron energy we go to, the broader peak our Dmax and 90% isodose line starts to display. So this is 12E. Now if we look at this curve, my skin dose is 90%, Dmax 2.8 centimeters, and if I trace down the tangent of my dose fall off, I end up right around 6 centimeters for a practical range. And now my Bremsstrahlung tail is at 2%. So my Bremsstrahlung is increasing. If I go from 12E next to 16E, notice what ends up happening in the 95% isodose line, or even the 90% isodose line, how wide it is compared to what it was at 6E. 50% and 30% have moved even deeper. And now if I look at my percent depth dose curve, my skin dose still just north of 90%, but now at 16 and 20E it's going to be even more noticeable. At 16, you notice that I have this real broad range. So anywhere from 2 centimeters to 3 centimeters, I get 100% of the dose. And 90% of the dose basically goes from skin surface to almost 5 centimeters deep. If I trace down the tangent of the percent depth dose fall off, I get right around 8 centimeters for my practical range. The Bremsstrahlung long tail now is right around 3%. And finally, if I go to 20E, we hardly ever treat anything at 20E. My 90% is even larger. If I pull up my isodose or my percent depth dose curve, you can see that my skin dose is at 95%. So without even normalizing to the 90% isodose curve, the skin is getting 95% of the prescription dose, which is basically full dose. So there's not really much skin sparing effect with 20E. However, I can treat deep. I can treat down to, almost 6 centimeters, at 90%. The problem is that if I normalize to 90%, my skin dose is going to be receiving 105% of the dose. So that's the drawback with 20E, which is why we don't use it very often, because if you're treating something that's 5 or 6 centimeters deep, you might as well use photons because the skin probably isn't the target, and it's going to be receiving full dose. For my practical range, if I trace the tangent line down, I'm right around 10 centimeters, and my Bremsstrahlung tail at 20E is 4.5%. So we've gone from just under 1% to 4.5% at 20E. And my profile has gone from this at 6E, this is 9E, this is 12E, 16, and this is 20 MeV electrons. So that's how the percent depth dose changes as we increase energy for the electrons. Let's look at isodose. Here's 6E. Here's 9E, 12E, 16E, and 20E.